Hello, friends. We'll begin doing question paper 61, year 12. So, let's begin. So, let's start to write. What happened? What happened? So, let's start to write here by using this tool, and we'll use Evinor next condensed font and this color. So, let me increase the font so that it's quite big enough. So this will be a spoon. Not again. So spoon. It will be a tripod. And effervescence will stop. And then number 2, the iron will stop dissolving. So describe the effects of boiling the solution of iron to sulfate for several minutes. Crystals of iron to sulfate will form. So heat is given off when alcohols are burnt. A certain used apparatus below to find the amount of heat produced with 4 different alcohols, methanol, ethanol, propanol, and butanol will burnt. So you can see the apparatus and some methanol was put into the burner. The initial temperature of the water was measured. The burner was lit and allowed to burn for 1 minute. The flame was extinguished and the final temperature of the water was measured. The experiment was repeated with ethanol, propanol, and butanol. Complete the thermometer diagrams to record the temperatures in the table on page 4. Complete the table by recording the temperature rise for each alcohol. So there's nothing special there. They always ask you to do that. So this is originally 25. This is 26. This is 23. This is 24. And so this is 28. This is 39. This is 46. This is 53. So here the temperature change is 3. Here it's 13. Here it's 23. And here it's 29. Okay, so we have done this. Since I'm using a computer, I can't plot the results or draw a graph, but if I were able to do so, I would definitely do it. So you must know the formula of the alcohol CH3OH, C2H5OH, C3H7OH, C4H9OH. So note that they are asking you the number of carbon atoms in alcohol formula and the temperature rise. You'll have to plot these two not the specific alcohol. The graph C5H11. So it comes after butanol. So you just have to increase it by a bit. It has 5 carbon atoms. So just the effect of using copper can to contain the water instead of a boiling tube. It will not be good because copper is a good conductor of heat. It will cause heat losses thus making the results less accurate. Wherever I write more than the space allotted, it does not mean that you will also write more than the space allotted, because everyone knows that handwriting is always smaller than something typed by a computer. Coffee beans. Okay, so now question 3. Coffee beans contain caffeine and other compounds. Caffeine is a soluble trichloromethane in an organic solvent. A student obtained crystals of caffeine by the following method. Some coffee beans were crushed into small pieces. Hot water was added to the crushed beans to dissolve the soluble substances. The crushed beans were separated from the liquid solution. The liquid was allowed to cool and shaken with trichloromethane to extract the caffeine from water. The caffeine was crystallized from the trichloromethane solution. The caffeine crystals were checked for purity. So what apparatus can be used to crush the beans in stage 1? So of course pestle and mortar. How could the dissolving process in stage 2 be speeded up? So the beans must be crushed to very small, must be crushed to powder is better, powder. Draw a diagram of the apparatus used in stage 3. So you can draw a filter, the filter funnel and filter paper, and it's quite simple. How should stage 5 be carried out? By heating the solution for a few minutes. Then a cool glass rod must be dipped. Rod must be dipped into the solution. And the crystals that form must be removed. What method could be used to check the purity of the crystals in stage 6? So we don't know any test for caffeine. We can write the most easiest thing that we know about. Measuring its boiling and melting points and comparing with known data. So, a student investigated the reaction between aqueous lead nitrate and aqueous potassium chloride. An experiment was carried out using a measuring cylinder. 3 centimeter cubic of aqueous lead nitrate was poured into each of 6 test tubes in the test tube rack. The test tubes were labeled A, B, C, D, and F respectively. A burette was filled with aqueous potassium chloride. A 1.0 centimeter cubic sample of the aqueous potassium chloride was added to test tube A. A 2.0 centimeter sample of the aqueous potassium chloride was added to test tube B. A 4.0, 5.0, 6.0, and 7.0 sample of aqueous solid potassium chlorides are added to C, D, E, and F respectively. Using a glass rod, the contents of the test tube were stirred. The contents of the test tube were left to stand for 10 minutes. Using a 10 minutes, a ruler was used to measure the height of the solid in each test tube. The diagram shows 6 test tubes in a rack. Use a ruler to measure the height of the solid in each test tube in the diagram. Record the heights of the solid in the table. So, we know this. Remember to put 0. Oh yeah, wait. So, height of solid. So since I'm doing it on a computer, so this is at a scale, but I'll try to measure. But it'll be at the scale, never be the real size. So you guys measure it. I can't. So this is the first time actually they're asking us to measure something physically. So from your graph, find the height of the solid form within 3.5 grams. You'll just plot the graph, find this and plot the graph and do all of this. What type of chemical reaction occurs when aqueous potassium chloride reacts with aqueous lead nitrate? So precipitation reaction. Precipitation reaction. Compare the heights of solids in test tubes E and F. They are the same. I can see from here that they are the same. Because all the lead nitrate has reacted. Lead. Now we don't need to write this. So predict what happens if you continue with 3 further tubes with 8 centimeter, 9 centimeter, and 10 centimeter of aqueous potassium chloride. So the height of the solid would not change because the maximum height of solid that can be obtained from 3.0 centimeter cubic of lead nitrate, lead nitrates is X centimeters, or there's in millimeters. So you will have to write it like that. So what difference could be observed? The experiment was repeated using aqueous. What will be the difference? There will be a yellow precipitate. So just one improvement the students could make to the experiments to obtain more accurate results. So you read again, using a measuring cylinder. So you always know. So wait a minute. Let me just get back to original form. Yes, so improvement. Burette or a pipette is used in place of a measuring cylinder. Explanation. Burette or a pipette. Pipette is more accurate than a measuring cylinder. So that's all. So dilutes. So solid W was analyzed. W was a carbonate salt. So the test on solid W and some of the observations are in the following table. Complete the observations in the table. Test it with brown litmus paper. So it's ammonium. So it's ammonium, yes. So when heated, ammonia is produced. So it's ammonium carbonate, dilute hydrochloric acid. Effervescence is seen, or even better, in a more scientific way, observed. The gas turns lime water milky. So dilute sodium hydroxide is added to the solid W and the mixture heated. So pungent gas given off, so it's ammonium. Divide the gas ammonia. What conclusions can you? It is ammonium car. So stop rust. Solutions of chemicals known as corrosion inhibitors are added to water in steel radiators to reduce rust. You are provided with 3 different bottles of liquid corrosion inhibitors, R, S, and C, and some steel nails. Plan an experiment to test if this inhibitor is present in the corrosion of steel and which of these inhibitors is most corrosive. So number 1, we begin here. Iron nails are added to 3 different test tubes that contain an acid mixed in salty water. And cool amount. Maybe we can put this in the next line. Equal amount of the liquid corrosion inhibitors. Make sure that your spelling is correct. Inhibitors are added to different test tubes, or you can say that R1 is added to, and one is added to, only one is added to, only one is added to a test tube. Test tube. One is added to a test tube. One is added to every test tube. Test tube. And all of these are not needed. So number 3 is out. Oh, I guess I put a double space here. Note that. Only one is added to every test tube. The apparatus is left for a few days, for you can say week, and then the apparatus which rusts the most, which rusts, has an iron nail that rusts more, contains the weakest or the least effective corrosion inhibitor. So for example, better if you put something like this. For example, inhibitor Q is added to test tube 1, and there's no Q there, R only, and inhibitor Q is added to test tube 2. There's no RQ, and we can say that as S. Okay, so the test tubes are labeled with the inhibitor present and the apparatus is left for a week. The apparatus which has an iron nail that rusts more contains a least effective the apparatus that has iron nail that rusts low contains the most effective.
It's 6 o'clock.
Effective inhibitor. Okay, so now we are finished with this one. So let's open our mark scheme. There, now we will open our mark scheme here. So yes, so tripod, and this is a spatula, so my answer is wrong. It's a spatula. So number 1, effervescence will stop. Iron no more dissolves. Evaporation of water. Crystals form. Corrosion. Okay, so you can say evaporation and evaporation and of water and color change. Evaporation of water and color becomes darker to be mentioned. And then so how much did I get here? 1 mark, 3 marks, and another mark, 4 marks. 4 marks. So number 2. So 25, 26, 30, 23, 24. And then 28, 39, 46. 53, 29, 50, 58. And then 34, 3, 13, 23, 34. 34. So -1. So thermometer readings correct. So 1 wrong. And temperature rise is correct. So got 3 marks here. So plot the results obtained on the grid and draw a straight line graph. Show clearly on the grid. See. So temperature temperature rises more quickly copper is a good heat conductor. So I got 3, 7, 10. Here's a 10. 10. Pestle and mortar, the beans must be crushed to powder. Stir. 2 marks. So filtration. So 3 marks. 4 marks. Ration, crystallizing point, or description in fume cover. So maximum 2, so I got 6 marks. And there's 7 marks. So 7 marks. 7 marks here. So let me just write it down on the front page. 7 marks. And then so the one, so 1, 2, 4, 5, 6, 7, 1, 2, 4, 5, 6, 7. So let's say I got this correct. Because I didn't do it, I can't measure it from my computer. So I got 4 marks. Let's say I got another 4 marks here. 8, 11, the precipitation, 12, lead nitrate is all lead nitrate is here. Same. So they're the same, yes. So it's correct. So I'll count it at the end because I've lost count. Same height. That should have been F. Same height. So yellow precipitate, burette or pipette. Instead of measuring cylinder height, some more accurate. So how much did I get here? Total 19, and they didn't get any wrongs. So let me go to the first page and write down 19 there. 19. Then coming down, I get the next question. Yes, effervescence is observed. On lime water turns milky. Ammonia. Oops. I wrote this whole thing in another color with another handwriting. That's because perhaps. So effervescence is observed, gas turns milky. So E is ammonia, non-transition metal, ammonium carbonate. So no water, you must add water, x centimeter cubic. Volume of inhibitor added, observed after suitable time, minimum time 1 day, repeat using other inhibitors, observe comparison of results. So I've got a total of 6 marks here and another 7 marks here. So I'll go to the top page and then put 6 and 7 respectively. Let me change this. Red chalkboard. 6, 7. So you can calculate 4 plus 10. So 4 plus 10 plus 7 plus 19 plus 6 and 7 is 13. So I got 53 out of 60. 60, isn't it? So let's just check it on the front page. Yes, 60. So divided by 60 is equal to. Okay, so this is, I got 89% here. So thank you very much for watching this video, and I'm sorry that I had to cut the video into 2 parts.